Hello guys, welcome to this comprehensive video on object-oriented programming for BTech CSE students. In this session, we will explore the foundational concepts of OOPS, which revolutionize the software development. We will start with a brief history of OOPS and highlighting its revolution and the programming languages that brought it to life. Then we will delve into the core concepts like classes, objects, encapsulation, abstraction, inheritance, and polymorphism. We will also discuss the advanced topics, the design principles, and real-world applications. So, by the end of the video, you will have a solid theoretical understanding of OOPS and its significance in the modern software engineering. So, let's get started. At first, the introduction to object-oriented programming. Object-oriented programming is a programming paradigm centered around the concept of objects, which can represent the real-world entities. These objects are instances of classes that encapsulate the data and functions, allowing for modular and reusable code. Object-oriented programming models the real-world problems more intuitively, promoting the better organization and structure in the software development. Languages such as Java, C++, Python, Ruby are known for their strong support of OOPS principle. By using the object and classes, object-oriented programming enhances the code maintainability and scalability. It allows for the creation of complex software systems that are easier to understand and debug. The paradigm also encourages the reuse of existing code, reducing the redundancy and effort. Originally introduced to improve the software clarity and quality, OOPS has become a fundamental approach in modern programming, aiding in the development of robust and efficient applications. Through encapsulation, abstraction, inheritance, and polymorphism, object-oriented programming provides a powerful framework for addressing the diverse programming challenges. Now it is time to discuss about the history, the evolution, and the programming languages of object-oriented programming. So, object-oriented programming began in the 1960s with Simula, the first programming language to introduce class and objects. Smalltalk, developed in 1970s, expanded these ideas, emphasizing the objects and message passing. In 1980s, C++ emerged and combining the object-oriented principles with the efficiency of C. The 1990s marked the widespread adoption of object-oriented programming with the introduction of Java, celebrated for its platform independence and robust libraries. Python and Ruby, which appeared in the late 1990s, promoted simplicity and flexibility, influenced by earlier OOPS languages. The evolution of object-oriented programming has been driven by the need for modular, maintainable, and scalable software. Modern languages like C#, Swift, Kotlin continue to advance the object-oriented programming, integrating the features that enhance the developer productivity. Today, object-oriented programming is a core paradigm in software development, influencing how complex systems are designed and implemented. Its history reflects the ongoing quest to make programming more intuitive and efficient and aligned with the real-world problem solving. The journey of OOPS showcases its importance in developing the robust and efficient applications. So now it is time to discuss about the core concepts of OOPS. At first, classes and objects. So, in object-oriented programming, classes and objects are fundamental concepts that define the structure and behavior of a software system. A class acts as a blueprint or template from which objects are created. It defines a set of attributes and methods that the object will possess. Attributes represent the data or the state of the object, while methods define the behaviors or functions that the object can perform. Objects are instances of classes, embodying the properties and functionalities that described by the class. Each object has its own unique set of data, although it shares the same methods as other objects created from the same class. This enables the creation of multiple objects with the similar structure but distinct states. Classes provide a means to encapsulate the data and the behavior, making it easier to manage and organize the complex systems. The use of classes and objects promote the modularity, allowing the developers to model the real-world entities, their interaction within the software. By structuring the code into classes and creating objects, object-oriented programming helps in achieving a clearer and more maintainable code base, facilitating the easier management and extension of software applications. So now it is time to discuss about the 4 pillars of object-oriented programming. The 4 pillars of object-oriented programming are encapsulation, abstraction, inheritance, and polymorphism. These principles provide a framework for building and managing the complex software systems. So now it is time to discuss about the first pillar, encapsulation. Encapsulation in object-oriented programming is the principle of building or bundling the data and the methods that operate on data into a single unit or class. It involves hiding the internal state of an object and requiring all interaction to be performed through the object's method. This approach ensures that the object's data is protected from the unauthorized access and modification, preserving its integrity. By exposing only necessary parts of an object's functionality while keeping the internal details hidden, encapsulation simplifies the interaction with complex systems. It also enhances the security and reduces the risk of unintended interference by controlling how data is accessed and modified. Encapsulation supports the modularity and the code maintainability by isolating the changes within the class, minimizing the impact on the other parts of the system. This principle helps in managing the complexity by providing a clear and controlled interface of interacting with objects. So now it is time to discuss about the abstraction in object-oriented programming. Abstraction in OOPS is a concept of simplifying the complex systems by modeling the class based on essential characteristics while hiding the irrelevant details. It allows the developers to focus on the high-level functionalities and the behaviors of objects without needing to understand their internal implementation. Abstraction is achieved through the abstract classes and interfaces that define a common set of methods or properties that derive the classes must implement. This separation between the abstract definition and the concrete implementation promotes a clearer and more manageable design. By abstracting away unnecessary details, OOPS helps in reducing the complexity and improve the code readability. It enables the creation of generalized models that can be specialized later, facilitating the flexibility and reusability. Abstraction also aids in designing the systems that are easier to extend and maintain, as changes to the underlying implementation do not affect the high-level abstraction defined by the abstraction. This principle enhances the ability to manage and reason about the complex systems efficiently. So now it is time to discuss about the topic inheritance. In object-oriented programming, it is a mechanism that allows a new class known as a subclass or derived class to inherit properties and behaviors from an existing class called superclass or base class. This relationship establishes a hierarchy where the subclass inherits the attributes and methods of the superclass, facilitating the code reuse and reducing the redundancy. By leveraging the inheritance, developers can create specialized classes that extend or modify the functionality of the base class without altering its original code. This promotes the modularity and maintainability, as common functionality is centralized in the superclass and can be shared across the multiple subclasses. Inheritance also supports the polymorphism, allowing objects of the subclass to be treated as objects of the superclass. This enhances the flexibility and the ability to manage the diverse object using a common interface. Through inheritance, OOPS enables a more organized and structured approach to designing complex systems by building on existing components. So now it is time to discuss about polymorphism. Polymorphism in object-oriented programming refers to the ability of different classes to be treated through the same interface, enabling the objects of various types to be used interchangeably. This principle allows a single function or method to operate on object of different classes, adapting its behavior based on object's actual type. Polymorphism can be achieved through method overriding, where a subclass provides a specific implementation of a method that is already defined in its superclasses, and method overloading, where the multiple methods with same name but different parameter exist within a class. Okay, so this capability enhances the flexibility and code reusability, as it allows for the implementation of generic algorithms that can be handle various data types and operations. By supporting polymorphism, OOPS enables developers to write more adaptable and extensible code, making it easier to manage and scale the complex systems. This principle also fosters a more natural and intuitive interaction with objects, improving the code readability and maintainability. So now it is time to discuss about the advanced concept in object-oriented programming: constructor and destructor. In OOPS, constructor and destructor are special methods used to manage the life cycle of object. A constructor is a method that is automatically invoked when an object is created, initializing the object's attribute and setting up the necessary resources. It ensures that the object starts with its life in a valid state. Constructor can be overloaded to handle the different initialization scenarios based on the parameters provided. On the other hand, a destructor is a method called when an object is destroyed or goes out of scope, allowing for the cleanup of resources and the release of memory. It is used to perform any necessary finalization tasks such as closing files or freeing allocated memory. Together, constructor and destructor help manage the creation and destruction of objects, ensuring that the resources are allocated and released appropriately, contributing to efficient and reliable software systems. So, access modifiers. Access modifiers in object-oriented programming are keywords used to set the visibility and accessibility of class members, including the attributes and methods. They play a crucial role in encapsulation by controlling how and where class member can be accessed. The most common access modifiers are public, protected, and private. A public member is accessible from any part of the code, offering a latest or least restriction. A protected member can be accessed only within the class itself and its subclass, providing a balance between the accessibility and protection. A private member is accessible only within the class it is defined, ensuring the highest level of encapsulation and protecting the internal state from the external manipulation. Proper use of access modifiers helps to maintain the data integrity, enforce encapsulation, and manage the complexity of the interaction between the different parts of a program. So now it is time to discuss about object-oriented programming design principle. First, SOLID principle. SOLID is an acronym representing the 5 core principles of object-oriented programming and design, aimed at creating more understandable, flexible, and maintainable software. The single responsibility principle states that a class should have only one reason to change, meaning it should have one job or responsibility. The open or closed principle OCP suggests that classes should be open for extension but closed for modification, allowing system to be extended without altering the existing code. The Liskop substitution principle asserts that objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. The interface segregation principle ISP. The interface segregation principle advocates for designing the interfaces that are client specific rather than general purpose, ensuring that the implementing classes are not forced to depend on interface they do not use. The dependency inversion principle recommends that high-level modules should not depend on low-level modules, but rather both should depend on abstraction. Together, this principle guides the developers in designing the robust and adaptable software system. So now it is time to discuss about the design patterns. Design patterns are standardized solutions to common problems encountered in software design. They represent the best practices that have been proven effective over time. Design patterns are categorized into three main types: creational, structural, and behavioral. Creational patterns such as singleton and factory method focus on object creation mechanisms, aiming to control which classes to instantiate and how. Structural patterns like adapter and composite deal with the consumption of classes and objects, facilitating the design of flexible and efficient structures. Behavioral patterns, including the observer and strategy, address the interactions and the responsibilities among the objects, optimizing the communication and coordination. Using design patterns helps in creating the scalable and maintainable code by providing the reusable solutions and improving the design consistency across the different projects. So using design patterns helps in creating the scalable and maintainable code by providing the reusable solution and improving the design consistency across the different projects. They also promote a shared vocabulary for discussing the design issues, aiding in better communication among the developers. So now it is time to discuss about object-oriented programming in software design and its application. OOPs play a crucial role in software design by structuring and organizing the code in a way that models the real-world entities and their interactions. It emphasizes the use of objects and classes to encapsulate the data and behavior, promoting the modularity and reusability. In software design, OOPs facilitates the creation of complex systems by breaking them down into manageable self-contained units that interact through the well-defined interfaces. This approach improves the code maintainability and scalability, as changes to one part of the system have minimal impact on others. OOPs supports the principles such as encapsulation, inheritance, and polymorphism, which help in designing flexible and extensible software architectures. By using OOPs, developers can create the systems that are easier to understand, test, and modify. The paradigm also encourages the use of design patterns and best practices, leading to more robust and efficient software solutions. Overall, the OOPs enhance the clarity and organization of software design, making it easier to manage and evolve over time. So at the end of the video, thank you for joining us on this journey through the object-oriented programming. We have covered the evolution of OOPs, its core principle, and its impact on modern software development. By understanding the concepts like classes, encapsulation, inheritance, and polymorphism, you now have the tools to apply object-oriented programming effectively. If you have any questions or need further clarification, feel free to reach out. Don't forget to explore the additional resources and continue your learning journey. Subscribe for more insightful content and stay tuned for our next topic. Until then, happy coding. Okay.